The range of possible values for a joystick axis is -1 to +1, and whenever the joystick is at rest, the value will be 0. So for example, if I move the left joystick all the way up the y-axis, I will get a value of +1, and if I move the joystick all the way down the y-axis, I will get a value of -1. Any position in between will result in a decimal value being passed to the event handler. I will actually be using these values to calculate the speed at which the motor should run, but first I will tackle the easiest case of when the value is 0. When the joysticks return to their central resting places, which typically means that the user has let go of the joysticks completely, I want the motors to stop moving. This is the equivalent of releasing one of the directional pad buttons we saw a couple lessons ago. For this case, I will say if the positional value passed in is equal to 0, then I will call motor.stop. Otherwise, if the position is not 0, I know the joystick is either being moved up or down and that the motor needs to move in the corresponding direction. Since I will get either positive or negative values, I can say that if I see a value greater than 0, then I should call the forward function on the motor, and if I see a value less than 0, I should call the reverse function. Now that I know which direction the tank should move, the final piece I need to add is a calculation for the actual speed. As we know, the positional values will be anywhere from -1 to +1, but as I covered in the previous lessons, the values accepted by the motor's forward and reverse functions is actually 0 to 255, so we need to map the positional values from the axis controls to the speed values the motor objects will accept. Since a value of 1 is the max value of this axis range, it should equate to 255, since that's the max value of the speed range. Furthermore, an axis value of 0.5 should equate to a speed value of 127.5, and so on and so forth. So to get the desired speed, I can simply just multiply the positional value by 255 and assign that result to a variable that I'll call speed, which will then be passed into the forward and reverse functions. Now at this point, with the calculation as it is now, we can actually get a negative speed value if the positional value is below 0. So essentially, this calculation will work just fine for moving the tank forward, but not for reversing the tank, as a negative speed value is essentially the same as passing in a value of 0, so the tank will just sit there. We can resolve this issue pretty easily by taking the absolute value of the position before doing the multiplication, so I'll just wrap the position variable with a call to math.abs. Alright, that should wrap up the code for being able to control the tank using the joysticks, so let's run the updated application in PowerShell and see what happens. And I'll go ahead and pull up the camera window again so you can see this in action here. And I'll first move each joystick independently so you can see the corresponding motor move independently as well. Cool, now push them both up, moves forward, push them both down, moves backward, and then one up, one down, then reverse, and you can really just sit here and do donuts, which is pretty solid. So I'm trying to avoid the cord again. Alright, seems to be responding pretty well. A little glitchy with the right motor again since I'm having issues with that motor shield, but overall this is a lot of fun. Very good. Well, that's all I have for you in this course, and I hope you had just as much fun with this project as I did. As always, if you enjoyed watching this course, I encourage you to check out the other courses I have published on the Dev Mashup website. Thanks for watching.